Okay, so I think, as I said, like we should do such sessions more often, like every other week, whenever we have time. And I think we can just start by me sharing the fundamentals, the basics. We see what questions arise, and we will see pretty dynamically where we need to go and what we want to explore and what we need to find out. I do not know everything about Gradle as well, so if we stumble across something that does work or we all don't know, we just try together to find it out. Basically, this is like for all of us to just get better at Gradle. That's the disclaimer. Now let's start with the very fundamentals. Here I have a Gradle project. I have just set it up like using a random 8.5 Gradle version, what IntelliJ generated for me. And the only Gradle file I have is like an empty build Gradle KTS. So what I would like to do is like get started with the very, very basics, as in like tasks, and how tasks can share files between different projects, because this one is very close to how dependencies work and how issues from configuration cache and how everything will work. So I just riff and we just create some tasks. We'll create multiple projects, like sub-projects. And from there, we will see how you, for example, could share the output of a calculation between projects, and how you could select what you want to share, and how you can set up like the communication between sub-project A and sub-project B. Okay, so far so good. So under the hood, like everything in Gradle is just tasks. So let's start by doing a few tasks that will do certain things with up-to-date checks, and we will see how we can connect them, how they can depend on each other, and how we can run them. So I will use this Gradle W shortcut. Yeah, Eugene?
Just immediate question. Maybe it's for the late, but when I start also like this, just trying to create a task or something new for module, it's often I'm stumbling upon that I need to define ID and apply, well, some context, I guess, for the KTS file. Otherwise, in some cases, it doesn't work, and I don't understand why.
Yeah, you mean like we need to specify like plugins?
Yeah, I mean,
okay,
yeah.
We'll get to that. We'll get to how we write custom plugins and all of this magic, and build Gradle, how we do convention plugins, like all of this we can tackle. So just for record, I use Gradle W like this, but it's just an alias. Like if I type this GV, it's alias to Gradle W. So there's no magic in that. It's just like in my environment setup. Okay, let's start by, first of all, I think what we can do is like just use the root project here and do some tasks, connect them, run them, see how things work. So let's first see that when I use this in the script here, what this refers to is a project. So you can see like, okay, Kotlin build script, but in the end, like this is a project. This, we can do everything what a project can do. It's like, it implements project, if I'm correctly. And a project has tasks as a container. So we can just write a few tasks. So let's do a task. The first one that we call is like we create some file. And then I would like to do a second task that takes the output of the first task, that creates the files or generates some source files and zips them. That's what I want to do. And then later in the session, I would like to use those zip. I pretend that it's a jar in the end, and we use the jar file and consume it from from another project. And then we can see like, okay, what if another project wants to use files from this? So let's do it here. We call this generate sources. Okay, so we have now a task called generate sources that we created, and we will definitely not talk about differences for register and create so far. Just be assured you can add to such containers entities. They are called domain object entities. It doesn't matter too much. You can create them, you can register them. One is lazy, one is not lazy, and we will tackle like the laziness and configuration, cache compatibility, all of this in later sessions. So for now, we keep it simple. We just create things eagerly, or we just pretend that it's no difference, and we can just use register and create at the same place, and we don't care if it's eager or lazy. Eugene?
And the tasks property, you said that it is project. Is it like the global one, or like how modules are connected? Our modules are like
Okay. Yeah. Good question. So in Gradle, you will see that there's an entity like project. You can access this on every project by calling project. So build script, which implements project, also has the project property. So we have here project. And this project here basically means the project that is inside this Gradle KTS file. So let's quickly, just to demonstrate this point, let me add a second module. Note that Android developers call this module, but from Gradle perspective, all of those things are called projects. So what we call a project from Android, like this, what is the folder session 1 here, is called a build in Gradle, okay? So build and projects have a little different naming. So let's just add some settings, Gradle KTS file, add two projects and see what is like a project. So in the settings file, you see I don't need a settings file if I just want to use the root project. The root project is available here, so I don't need to tell Gradle that there's a root project. But I can just let me resync, so the IDE is helpful when I have a settings Gradle KTS. Okay, now I can do something like include, and we do something like let's call it foo, and we call include bar. We sync again. And now we should be able to see that there is a new directory foo. It's now already recognized as a IntelliJ module. We can do a build Gradle KTS. We need to resync, so it loads the script configurations. Okay, now we see here there's a project as well. And what this project means, basically it's the same. Like I can do something like, well, the X, which is a project, is this, right? So there is in a build script, there's this implicit receiver that is like the project that you currently in, which means like this is foo. So if I do a task here as well, so let's do inside here, let's explicitly use project task. We don't need to projects prefix and create, and we do an X here. And we call, let's copy paste and do a bar, the same thing for bar. Let's sync again. You see now bar and foo, they both have X. What I now can do is like I can execute foo X. So now it's like I want to execute the task foo X. But if let's call it something different, like let's call it bar on bar. So if I want to go bar X, you will see like, okay, there's no task X found, but I know that there is now 1 second. There, it should now be, I don't know why there's now a bar. Okay, it does something. So meaning this tasks, if we want to just list all tasks that exist, we could do something like project, yeah.
Yeah, just one question. If the task is in like sub-project, sub-module, do we need to specify the sub-project name every time when we invoke the task if the task name is unique for the...
Oh, no. I can just do X. And what it does is it will invoke all the tasks called X in the whole project. So that's why you often see like Gradle W, compile, Kotlin, blah, blah, blah. And we can just use this as a shortcut to execute every X. So I see here we have bar, just define a bar. I should be able to just do Gradle W bar, and it will do this. And you can also see that there is now something like in this build script, I just wrote code that goes to tasks. A container is implementing eachable. So like for every task, print the name, and you can see like it now prints bar, build environments, components. And you can see this. One of the best tricks I can share with you is debugging Gradle. You often don't want to even specify any task. You just want to say like configure the build. Then you'll just do Gradle W. And you now see that even though I am just doing Gradle W, it runs this code, this particular code. And now you can see, okay, it created this task bar. And now you can see there are some tasks that are, okay, model, Java toolchains. Like this is coming from Gradle. It's great. So you always have these tasks. You have a help task, but you also have this task that we just created. And this is just for the project. So to get back to our root project here, this task can...
To add on this, so when you run just Gradle W in the root, it will execute all build.gradle.kts scripts and their code. And since when you create task, the task is executed like a lambda, lazily, right? You need to invoke it explicitly. You just execute statements in the root of the file. Basically, that's
we will see one of the common pitfalls in a second. So let's just clear foo and bar projects. And yes, exactly. Gradle, what Gradle will do is like it has phases. First phase is like building the build SRC, compiling settings, Gradle KTS, figuring the class path. But at some point, something that is called configure. You can see here also in the terminal says like configure project. Now, configuration phase is where it's actually running code and build scripts and plugins to see what tasks need to be there, what outgoing variants are, like how projects connect with each other, what are dependencies. So this is all the configure phase. And once it knows what tasks you want to execute, it will go to the task execution phase. Everything is configured. As ideally, it configures as little things as possible, which is like why you would see in a pull request, if you create a task with task create in any of our repositories, some engineer will go and say like, no, you cannot do this, because I can tell you something here. Let's do something here. Print line, generate sources and say hello. So this here, like this here is the task that we just created. Generate sources is a default task, like generic task that we created. A task has an action, inputs, outputs. It's the default task here is if you don't specify something, so we can also go and say like, okay, this is a default task. So yeah, not really that interesting. Let's go and say print hello. Now, if I just do Gradle W, you should be able to see that it still prints hello. Even though we did not even want to execute the generate sources task, it says hello. And this is one of the common pitfalls that you can see people doing when they write like code for Gradle. It does too much. So we could theoretically, and I said I don't want to talk too much about the laziness of register versus create, but if I do the same thing here, it will know that, okay, nobody cares about generate sources task. So this lambda, without calling this as a register, it will be kept, and we will only invoke it when somebody really needs this task. So we will create the task and call every configuration block on it. So we return you the instance that you actually want. So we can still go with hello with this register here. Doesn't matter too much for our Gradle workshop to understand the basics. The task container, we can say to such containers we want to create an entity. We give an entity a name, and we can configure the entity. And we also could give the entity a type. So for example, we can do a Java exec task. Let's not go into too much detail. Let's do this register here, and let's write some code that will, in our build directory, create us a source file or something that resembles a source file. So we can go and new approaches for getting the build directory is this. We can say like a file. We say like source. Let's do a directory. Let's call it generated sources. So we just go and like tell Gradle, okay, layout is something that is like the build layout, like where are the files located, and we say like, okay, we want to know about the build directory. So the generated sources directory, we can just get this generated sources directory. We can also do as file, and then let's see, get and as file for now. So we just have a plain stupid generated sources. So let's just execute and see what it does. So we can call generate sources, and since I'm lazy in Gradle, the next trick is you can invoke, you can specify generate sources, Or you can also just abbreviate it by GS, because like that's like first letter and then all the capital letters. So you can just do GS to call generate sources. And what we should now see is like, okay, now we created this generate sources. Okay, now let's go and to this generate sources directory. We create a new file and let's call it hello.kt. And then do something like write text, and we say like class hello, and that's it. Okay. So if we do GS, okay, we see now there's a generated source. It's like a hello, and it does do the thing. So if I now call GS again, let's do dash info. Now we get to this interesting part. It says up to date as it has no actions. What we would like to also now see is like, how does this up to date check work? We would, let's say, if I just delete this, we will see it is still up to date, and it does do the hello. So there's something really strange. The task didn't do anything. It says like it's up to date. It skipped the task, but we still generated the sources. So there's some issue already, and I will share in a second what we are doing wrong here. For now, let's continue doing a second task that builds a jar file for us. Like just pretend that there's a real jar file, and then we'll fix what is going on. And I hope that there's some learning from the mistake that I purposefully did already. So we have a task. We call in the task, like create this hello class, hello KT file. So now I want to have another task that builds a jar file. So let's call this jar. The task is called jar. And now what I want to also say, like, okay, this is a jar task. I can reuse the jar task from here, or I could just again write my own logic that zips files to jar. So okay, what do I do? I would need to get this directory, and I would like to put it into a jar file. So first of all, I define, since this here is now this now is a jar task. I can specify like some things on this task. I can say like where the archive file is. So we can do like destination directory equals destination set. And what we do here is again layout build directory. Here we saw like let's call this binary, so bin. Then we say archive file name set, and we just call this one here hello.jar. And what we do is like we say what we actually want to zip. So we also go and say like we want to zip, and I just copy paste code. Oh, we just zip like this directory again. Okay. So if I do this, and I purposefully have still some like plenty of issues. So let's call the jar task and see what it does. Okay, there's no binary. There's a hello jar. It has the hello file in there. Boop, boop, boop. So it's already pretty cool. We have now a task that is building me a jar file that just contains something. Like a jar file, as you know, is just zip with the .jar extension. And it has conventions about this meta inf. In any case, I just zipped something. And yeah, there's a source file in the zip. Who cares right now? Okay, looks good, right? We have created Gradle that has two tasks, and somebody zips, but there are plenty of question marks right now. How do those two tasks relate? What happens if I delete something here, or if I change the text here? Let's change the text here. Class, and like say do service, which is like a Bavarian way of greeting, and I do the jarring again. What it tells me is like one actionable task, one up to date. Okay, let's look into this one. It didn't change anything. So certainly I violated a bunch of Gradle rules, and it is not working properly. So if we just do the jar-info, we again see up to date. And here comes one of the most interesting things. So first of all, like first mistake, those two tasks don't know about each other, but they have dependencies on each other. Like basically, here's a task that creates outputs, and this task needs this input to work. And this would also be how Gradle would know if there's something to be redone, because if the output or input from some of the tasks changed, then it needs to rerun it. But you can see like nowhere I declared anything like this. So what we would need to do is to go and say like, let's just write some code here. So we say like generated source text equals, I just put it on top here, class. This would be coming from like users downloading things like some file that a user created. We can also do some source files and transform it. In any case, I'm just hard coding something here, and I just do generated source text here. So first things first, this code here doesn't know that the input of this task is also like whatever is defined as what we actually want to generate. So what we can do is here inputs, and we can do property, and we say like text, and we say generated source text. So now every time we change the source text that we actually generate, Gradle will know, aha, the input of this task changed, so I need to rerun it. So if I change this, and it's again could be coming from somewhere, the network, whatever, like we just pretend that it's coming from what the user did. Yeah, Eugene?
But how does it know? There's like some cache, or like how does it know?
Yeah, here it's like you declared that this input, like this task has input, and
No, I see it, but like in between executions, like is it stored somewhere that?
Yeah. It is stored. What all of those inputs are hashed and stored. So the next time, let's now rerun the generate sources. Okay, you will see now generate sources -info up to date, and now it says like has no actions. Really strange, really strange. Let's just go back. Let me just delete the build directory. And now let's just execute Gradle again. I did not specify any task. Aha! It still generated the sources. It's as if executed this task. And here's like beginner mistake one that you always run into. Inside this block here, this will be used to configure the task. That's not the place where you put the code when the task runs. So here, now all of this was basically just me doing the tasks job when actually Gradle asked like, hey, how can somebody please configure this task? And then when it wanted to execute the task said like, I have no action, like I have nothing to do. So what we need to do is, you will see this, in order to specify the task action, you wrap the code in do last or do first. That now says to the Gradle task, hey, here I configure you. We can do something like we can do like a task description. So my task to generate sources, and if I now sync, the ID will the ID will show me this task with a nice description. So we can see here other generate sources. They don't know how I can actually see the description of tasks, but we can do something like tasks. Or we can do something nicer. We can do something like group and say like tutorial. And now you should see that, yeah, there's now a new tasks, group of tasks that the ID shows. And it says like, oh, the generate sources is under the tutorial group. Okay, like we can remove the group, doesn't matter. So here is just like telling Gradle everything it needs to know about, like, hey, this task would depend on another task. This is the input to the task. This is the output to the task. And this action, like the action when it actually should run, is wrapped inside do last. So Gradle first configures all the tasks it wants to know something about. And then it actually says like, okay, now let's move to executing the task. And then it executes these actions. So We told it about the inputs, but we did not tell it that it actually also has an output on disk. So what we need to do is, as outputs, we should get this directory and also do outputs directory, generate the source directory. So now Gradle knows two things. Let's remove this. Let's tell Gradle about inputs to the task. Tell Gradle about the outputs of the task. So, and then here is like what this task actually has to do. So here it says like, okay, we have these inputs, basically something like this. We still pretend this is coming from user or us reading a file. Like, for example, compile task does something like the inputs are all the files that the user wrote. Source files, outputs are my class files that I produced. So if somebody wants to zip it, he knows about that. This is these are the outputs. Like they might get dirty. So okay, let's try this generate sources once again. So we run generate sources. Okay, it says one task executed. Let's do with -info again. Okay, up to date. Generate sources contains the text. Now let's change this text. Run again. And you see generate sources is not up to date because one or more additional actions have changed. Usually it can also tell you what actually has changed, like what is the input that changed. It's not up to date. It now changes also because I have this build this inside directly the build file. So what we can also do, like look at this test. Now I can also delete this file. And since we told Gradle about what the output was, Gradle is now clever enough to track and see like, okay, somebody messed with the output. So it was deleted, cleared, cleaned, whatever. So if I would request this task again, it will now say that generate sources is not up to date because this file that we declared output property has been removed. Okay, it redid this this task because it was removed. So let's run it again and see like, okay, everything up to date. No need for rerunning this task. Pretty neat. So now it actually just runs this block, which does the heavy lifting, when actually there's something that we need to do. Okay, we have now declared this generate sources properly. We know what this task depends on, declared as inputs. We know what this task produced, declared as outputs. So we probably have hard times actually breaking this. This is pretty properly done. Okay, now we want to create this jar file. So let's again delete the build directory. Let's do the task that creates us the jar file. Build binary hello jar doesn't contain anything. Okay, why? Because actually this task has no idea that it should even depend remotely on this other task. It knows that it has the same output directory, but it has no connection to like, hey, this task actually depends on that. So what we can do is we can do a very simple trick and we say like, you depend on the task called generate sources. So that's not the nicest of doing it, but let's go. Now you see that, oh, that generate sources seemingly was done. And now it also packaged this hello KT. Okay, so what happens if I just in the middle delete this again, do the char -I, and let's see what the output is. It says like jar file or jar up to date. Why was it up to date? It was clever enough to figure out that, okay, it needs to read on generate sources, but then it is able to figure out that the inputs from the, like since we put the same file again on the disk, we know like, okay, previous run had the same inputs, outputs are still fresh, so we don't need to redo it because it was the same operation. Like we did just the same thing again. So now we have a jar task. Yeah? Yvosha?
Yeah, so does it mean that the Penson is caching the output of generated sources as an input for the current task? So
yes, it is. It is at least telling that this task needs to depend on like this task to be executed. And where we told Gradle about the inputs is basically this jar task. That's a lot of heavy lifting. If you call from, it basically already means that this directory actually should be tracked as an input. So this call does not do it for you, but this call does.
Okay, so depends on is basically just the dependency on the previous task. It specifies the order. Okay.
Yeah, we can do something like capture the task, generate sources equals task create. So now we have the reference to the actual task here. We can just do it. We also can just pass directly this. So again, if we do jar up to date, and what we also can try is to do something like from and like tell it like, please zip what the output of this task is. So let's try this one. Still up to date. Let's delete this. And it's successful. Binary hello jar. Okay. So basically what we told now Gradle is, hey, there's a jar task. From is basically everything included in a zip or jar file. Same thing here. It's like if I call this just zip, everything works as well. So jar is just extending zip. Extends zip. Yeah, that's the magic. Jar is just a zip with some extras on top. Okay, here we just basically say like, hey, all the outputs from this task are the inputs from our task. Please put them in the zip file. Please put them in this directory. And here's the name of the file, so hello.jar. Great, we have created this. Now let's look on how, for example, this jar task was built. By me showing you also how to do this custom task classes, because most of the time, if you would really go heads down deep into Gradle, you wouldn't write tasks with this DSL. You would write something similar to this jar. So let's rewrite this generate sources into a generate sources task that we can just reuse, for example. So let me quickly just do git add and git commit dash m. Let's call it just save point 1. Right, so we can look at the Git history and see, okay, at this point this was the state. So if somebody would like to look at it later on, once again, you can. So let me show you how you would write tasks properly, as in like you writing Gradle plugins. Like how would you write a task properly? Because this is not how plugins would generate tasks. So what we can do is we create an open class generate sources task, and this implements default task because we just want to extend the default task. We don't want to do something. Interestingly enough, you will not be able to write a final class because Gradle at runtime will do a lot of magic and will create a custom implementation of your abstract class to inject some services into it. Because inside a task, you will get access to projects and like to some internal things that you don't want to all request in constructors. You just have access to them. In order to make this happen, Gradle will subclass your tasks, and therefore you cannot have a final class. You always have to do it abstract or open. You will see in most code bases that use abstract classes. I don't like abstract classes as an approach because it's really hard for you to figure out what you actually still need to implement from your own code base, because some of the time you will have like your own, like you will subclass a task from your own class. And as much as I hate abstract classes, this is the reality of things. I would like the compiler to complain if I forgot something. If you forget it, just make it abstract class, pass it to Gradle to instantiate. Gradle will tell you at runtime just like, hey, nobody really implemented this method, so you screw you, runtime exception. So I prefer open. That's my advice. You will see that this is not a widespread strategy. Let's continue with making it open. So generate sources task. What we want to have is like we want to make sure that somebody can give us like what is the source that we write somewhere. So basically, we want to make this task configurable, so you could have multiple generate sources tasks. So I want to say that somebody can provide me with a property to set the text. So I do something like val sources. Let's just call it sources, and it is a property of string. Gradle likes to use properties. You could also just use a regular string, but let's just go with the properties. And we can do either project dot properties dot or like project dot objects dot property, or you could make it abstract and let Gradle do a lot of magic for you. I prefer, again, the simple route. Less magic is better. So we now have something where you could theoretically set sources. So let me quickly just comment this out, and let's do val generate sources equals tasks create. Now tell Gradle generate sources task. We call it generate sources, and now we can do something like sources set, or with newer Gradle versions like this, and we say like hello class hello. Okay, so now we have like a way to configure this task. We now have like a way to tell it about what the sources are. Now we would want to say where to put the source. So maybe we should do something like like a file property that we can specify where should we locate the source. So let's do say output file. So let's do a regular file property. I was quite nice. So yeah, we have output file. So what we do here is like we can say output file equals build like layout. Now we just need to specify where this is. Dear generated sources dot file. Oh, what second map? No, not map. Get file, and now we call this one. What did we call it? Hello KT. Let's call it hello KT here again. So we just pointed to where the file should be located, right? Okay. Next thing, Gradle has like needs still to know like what is considered semantically the input, what is like the parameter to the task, and what is the task producing. We do this by annotating, so we can see something like we can do this like input file, like no, we call this input, and we call this output file, for example. We just have annotations, and that will tell Gradle like, okay, this is the input to the task for up-to-date tracking. Here's the output to the task. Okay. Now let's see if Gradle does it. If I remember correctly, Gradle at some point had issues like defining such tasks straight in the build script. Potentially, we just need to have a build source where we can quickly locate the file, this task. But let's just try out if it works even inside this. So let's do clean and see that we don't have a clean task. We need to, because we have no plugin. Let's quickly just do a create clean. We can use the built-in delete task, and we just say like this dot clean or remove. I think it's delete. Yeah, delete, and then build the layout, build directory. Yeah, we just say like the clean task is now defined as like delete with the build directory. So let's clean. Build directory is gone. Let's put that one also somewhere where it doesn't bother me. So we have here the jar task. We have here the generate sources task. And of course, we can have now with this task here defined, we could also have like generate sources here, and we can have another task that generate sources too. And we say like it should put out foo instead. So you get the point why it's nice to have a class where you can just like have then something you can declare how the task should behave, how you want to prioritize it. And then you say like, this is my generate sources task 2, generate sources here. And basically this is more like a prototype. Yeah, Ivasha?
Yeah, one question about tasks. So far I get all of these input outputs, but when you define the class for a task, does Gradle supports constructor injection or something like that, or it's encouraged to do just properties directly in the class body?
Yeah, it supports constructor injection for some of the things you want to do. I personally never liked it too much because it is kind of impractical. I can give an example. You can even inject custom properties. So let's request something like x as int. And what you can do here is like, if you create this, you can actually provide, I'm not sure if it's in task. Yeah, you can here now provide arguments, and then it will match. Like you will now need to provide 1 or 2 or like something. Like you can now say like, I provide this as an argument 1.
Okay.
Yeah, arguments. It needs to be an array. You get the point, but that's one of the reasons why it's rather inconvenient to use, because there's no
it's not
verification.
It's
No,
not type safe, right?
not type safe.
Okay.
Yeah, now let's do the generate sources. And has somebody an idea of why I don't see something in the build directory already? So I call Gradle W, generate sources, nothing happens.
We
Any
didn't
ideas
specify behavior of the task, what task actually needs to do, right?
Exactly. So let me show you how this is done. We can do something like a protected function, and most of the time you will see this called do stuff, generate now in this case, or action. Let's just call it very stupidly action, and it needs to be annotated with task action. You can have multiple functions that are annotated with task action. And what we now need to do is just output file, get, create parent, let's do as file here. Well, output file, or let's do it like this, file.parent, make create parent file, write text, and now sources.get. Yeah, let's try this out. Generate sources. And yes, it created the directory. It put this in here. Yeah, Eugene?
Well, the first question which I would ask if I use this task, why not to provide output file name? So user just can't pass a string and you don't need to.
Yeah, we can do this. We can say like, if I would be the Gradle plugin author, I could do this as a decision of how would I like my users to use my API. So we can just do this as a string. We can say like, this would still then be okay. Now it's interesting because we would still need to tell Gradle, hey, we are still touching output file, but now the output file is basically protected. It's not something visible from the user.
Mm-hmm.
And we should now know that this is from build layout, now layout, build directory, here, generated sources. And then we say like file, or now we need to go lazy, can do something like map it.file, file, and now output file name .get,
Yeah, but
for example.
this is also design decision on whom do we want to push the responsibility of providing valid path to the file, right? Because
yeah, exactly.
With the regular file property, the user needs to provide regular good path to the file. With the string, we are the ones who need to do validation.
Yep, exactly. So in this case here, we can just quickly show how this would be done. So this one here is not annotated. It will fail now because it's not annotated, if I remember correctly. You should see like cannot access output file, blah, blah, blah. Oh yeah, output file makes sense. So let's do output file name and set it to hello.kt. Output file name. Oh yeah, wait a second. This is not where we want to do this. It is output file name, just for the sake of like having fun. We call this hello.kt. And here output file name, we obviously want to have output file as file. And let's see. And I think Gradle will complain because it doesn't, yeah, exactly. It's not static enough class. Class is a non-static inner class. 1 second. This might be one of the issues you run into if you would try to write classes in here that you use as tasks. So let's see what we can do. You get the point. Build class generator is non-static inner class. I think I cannot really. We can try if it helps if we do it abstract, but I think I cannot demo at this point.
Can we mark it in with the inner modifier? But I don't think we can't because it's not in the class.
Yeah, it's non-static in a class. It should be static, and we cannot force it to be. Yeah, I think like there's not a lot of things we can do to make it. But I told you that this is like something you would put into like build SRC in order to make it work. We can do this if you would like, or we can move on to like how would you use this jar from another project now? And for example, this would be mimicking how you resolve dependencies. So please vote. Would you like to see more like Gradle plugin development code? Like, let's move this into build SRC, pretend there's a plugin. How would you write a Gradle plugin? Or would you like to understand more about the internals of Gradle? Like, how would two Gradle projects communicate each other? For example, this will also help with understanding how some module sees the class files from the compilation from another module and how this actually invokes the tasks. Like if you compile module A, oh, it knows that it also has to compile module B and provide you the class files. I would think the second one is a little bit nicer to go in direction, but if you're really curious about how you would write Gradle plugins and more of this kind of code, then we can also go that direction. So please just vote whatever you think is more interesting.
Okay, I see how we write plugin code as implementation detail, and the second point more as an abstraction. So I would start from abstraction and later come to implementation detail. But for me personally, that would be logical. I just one question before we continue, and it's related to implementation detail. If you have multiple task action annotated methods inside the default task that you implemented, how do you specify the order?
I don't know if I can specify this with an annotation. Let's try it out. I was under the impression that it's the order of the methods, like the order of how you declare the methods. But we can try this out.
Yeah. So is it encouraged then to have only one per task?
Yeah. Yeah.
Okay.
It is definitely encouraged, because if you really care about the order, why wouldn't you order it by just writing the code here and then writing another function here and just making sure there's just one entry point? That's what I would say. Okay, so let's say we have, let's say, what do we want to do? What do we want to do? What is interesting? I think let's go actually like understanding how like projects communicate with each other. So in that case, we have foo and bar already. So I'll just close the tabs here, and let's go foo and bar and declare like bar using foo as a dependency. Maybe we should call it differently, and we have like a library and app. Maybe that's more easy to understand. Or maybe do you like to use consumer and producer? What do you think is easier? I think in a lot of examples, it's like consumer and producer, because it's not app and library. We just like something, somebody's producing something, some other parties consuming it. So let's sync again, rename, and call it consumer.
Maybe it would make sense to use KMP and multi-platform projects analogies with shared, with the apps, few apps.
Yeah, I'm not sure. I would say that it makes sense for now to keep as little of plugin namings and entities in the scope in order to avoid some potential confusion with like, this is just a concept from KMP or Kotlin, and this is actually Gradle concept, okay? Okay, let's look into the producer. Let's write something that the producer does for us, which is like, I don't know, it writes us something again in a jar file. So what can we do? Let's do something like let's sync to get autocomplete.
Yeah, it builds jar, and we need to use jar from another.
Yeah. Let's build 2 jars to make it interesting to see how we could have like how we could specify what actually work we want to do. So we have 2 jars. We call one task create, and we call one like production, or like let's call one. Let's create first jar file that. Let's just call something like utils and one is productions jar. So we call this main jar, and then we have like task create a utils jar. Okay. So what we do here is like we just create a jar file again by using the jar task. Again, has like just nice way of specifying where to put it. So destination directory. We set it to build file. Oh no, not build file. We'd say to layout, build directory, and then we say directory, and we say main, and then we say archive file, set of archive file name, set, and we say like main.jar. We do the same thing here for the utils jar. So it's also a jar task. Utils jar. Okay, so now we have these tasks, and we can, utils jar, and we can, for example, do something like the umbrella tasks, where this is also typical Gradle. You do something like jar, one task, and you just say like this depends on main jar, and this depends on utils jar. So I can just execute Gradle w jar, and it will just be an umbrella for both tasks to execute. So now in the producer, I see main. Oh yeah, and this should be utils. Yeah, now we see main and utils creating. Oh yeah, and this should obviously also be the utils jar. So let's delete them again and Gradle jar. We now have 2 jars created, main and utils jar, main jar. Okay, nice. We have a project producing jars. I would like to extract those jars in the consumer, for example, and see what's in there. Okay, so let's see how Gradle could actually do this. So let's say we have a task here in consumer. We call it like compile, I don't know. And what it actually wants to do is like what we could do if we want to say like, okay, there's a dependency to producer. We could really sneakily say depends on producer jar. So now we know that it actually runs this. This will, let's do compile. And we should be able to see, okay, let's do compile, try run. And this will show us what would be executed. And now we see like, okay, our consumer compile would actually call the jar task, which calls the utils task, which calls the main jar. So we could actually also really sneakily just say like, hey, if you already know about this, like we executed this task, we could know like where this is. So we could do something like copy path reference from repository root. And now we could do something like do last or do first, do last file. Let's do root project.file producer. Now we get actually the file. So we have like the main jar. And now let's do unzip. Unzip2, okay, DSL support. Unzip2, it's a strange function because output directory is build directory. Layout, still using the old APIs, layout, build directory, main unzip, get as file, and then main jar. Okay, now this task the compile task, we should now see that it actually should unzip to this unzipped. Okay, yeah, now there's some meta manifest. We can, just to make sure that we have something written in here, let's do manifest attribute, and we just say something like module, and we can say it's the main module. Oh, attributes, I think, how can we add some attribute here? 1 second. Set, oh yes, just set
Maybe as a map.
module. Yeah, set module, and then we call this main, just that we see something where stuff is coming from. So we can do this here, and because like it's not the most interesting of examples because there's not a lot of things happening, but I hope it still gets the point across. So now what we should see here, main unzipped.
I just fixed the aggressive P.
Okay. Thank you. So let's do it again. Compile. Yeah. Now main unzipped. We should see like, oh yeah, it actually was able to do this. Why is this bad? This is bad for several reasons. First reason, it reaches like it is hard coding several things that are kind of details of another project. Like, okay, you hard code the task there. You tell Gradle that it should reach into this other project, meaning the other project needs to be configured fully. So we would not be able to parallelize things here. And then, of course, you also need to completely hard code the paths here. So it's completely discouraged. If you would check and code like this into one of our repositories, build infrastructure engineers would hate you. Like, you have not understood Gradle. You are like the worst engineer of all time. Please never ever try to add anything to a Gradle file. So how would this be done properly? Okay, a proper way of doing this is the following. Let's say I have task compile. What I want to do is something like this: dependencies, then project. Like we need some configuration to declare dependencies on. Usually you see in Gradle plugins providing us something like implementation. Right now we don't have any plugin applied, so there's nothing where we can add dependencies to. We don't have something to add a dependency, but I would like to do something like implementation, project, and then I specify like, okay, I want the consumer. Yeah, and that should get me the consumer. And if I want to have like the utils, I should have like test implementation or utils implementation for the project consumer, and this should give me the utils jar. It's red. How can we do this? Okay. First of all, we would need to go to the consumer, to the producer. Oh, yeah, producer, of course. Like we depend on the producer project, and we want to have something from it. So now we need to basically go and tell this producer project, hey, here's something that can be shared. And now here comes something that is one of the most powerful concepts in Gradle, which has a name that is unfortunately not intuitive. It's called configurations. Configurations is, for example, this implementation in an Android project. This implementation would be referencing a configuration, test implementation, API, compile only, runtime only. All of those things are configurations that are either defined in the Java plugin or the Kotlin Gradle plugin. And what they do is they allow you to add dependencies, but also, because it's not just powerful enough, configuration is also the same concept that is used to share code or like outputs with the world, either publishing them or sharing it and declaring like, hey, the producer project, I can share these things like these files with you. How can we do this? Let's get started. So a project declaring that it can be used as a dependency can create such a configuration. So you can do something like configurations. And now there is a concept like Gradle. I told you that Gradle has this concept, and it does these two things. It can request dependencies and download them. It can also tell that this is something that can be downloaded. Of course, this is a heavy thing to do. And new APIs from Gradle are trying to make that a little bit easier by splitting this into two types of configurations. So you see consumable, resolvable. I have not worked extensively with those two things, so we'll figure it out. I would now just go with the configuration. It can do both. It's the heavy concept, and this is here to make it simpler. Consumable, resolvable. What is consumable? consumable is something that where this consumer project tells the world, hey, somebody could get these files, these artifacts, these things from me if it would depend on me as a dependency. So what we can do is here, let's try to use the consumable. It's incubating. And if it doesn't work, I'll fall back to just the regular configuration, and we'll figure out later sessions how we would use the new APIs. So we tell the world we can be consumed. So we go with a convention, which is like there is consumable configurations often suffix with the word elements. It's a way to indicate if you just read the name of some configuration to see, oh yeah, this is meant to be going out, like it's something that gets out. So here, main elements is where it can get out. So how can we tell this configuration what artifacts it has? Yeah, it's quite simple. We declare artifacts. We can do inside here, artifact handler. We can see that add, one second. I think the better way of doing it is there. Oh yeah, let's get references to jars. Main jar. Oh, let's call it main jar task. Okay, main jar task. Okay, we now have like we now should be able to say we have two elements. Then we have the utils elements. And now we say one offers the artifact of the main jar, and one has the artifact of the utils jar. Let's see if it configures. It doesn't. So yeah, of course, this one here was just example code. So let's not break because of it. Okay, it configures. So let's just pretend we can go to the consumer here, and we also need to have some container where we can add configurations. And then we will get to this question that you probably have. How could I then specify if I want the main or the utils from the producer? And we'll see this. So let's go and say we have a configuration. We call it implementation for now, just because. Now, let's not confuse with existing Kotlin Gradle plugin and Java concepts. We have a main configuration. It's configurations dot. Now this one is resolvable. You know, we do not offer something. We want to request something, so we use resolvable. And now what you can do is main project, and then basically just producer. So what's the problem here? Project dependency. Oh, this one here is giving us not the configuration. It gives us like a handle to configuration. Doesn't matter. This is actually what happens if you type implementation, blah, blah, blah. What this happens to is like, it's an instance inside this dependency block. If you look to this invoke, let's just go and do this invoke. This invoke comes from this dependency scope, blah, 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 blah. 1 second, go here again. It's not indexed, no sources provided, doesn't matter. But inside this dependencies block, you suddenly get an extension function on configuration, which allows you to add dependencies. There's a lot of magic. Let's not use that right now. Let's use simpler code. And then explain what this does. What this does is project, or like main, now project dependencies add main.name, project dependencies create, and then project producer. Basically, what this does is like this here is the concept of how Gradle will add a dependency to such configuration. It can do it by string. So here we add this the name or like this string to the configuration, and then configure like the dependencies are quite heavy to instantiate, so you can use a dependency notation like the string for Maven artifacts or just a project. And you can let Gradle create this dependency. So it gives you back a type of dependency. So org Gradle API artifacts dependency. We are lazy. We don't want to instantiate this for ourselves. Therefore, we use this create factory method. And this is exactly what this here does. This code, like inside the dependencies block, is just sugar for this. It goes to the project and tells, hey, please add to the main configuration a dependency that you instantiate with this notation. That's it. Yanni Boscha?
Yeah, just one question about resolvable and how we resolve main. So can you go one more time to where you specify this configuration? I think I might slip something there. So when you specify the configuration, yeah, you said main elements. So when you do the resolution, it matches against this main prefix, right?
No. Let's be stupid and just call it X. Like to make it clear that the names that do not matter. So
okay.
I want now to have a compile task that uses whatever X gives us as files.
Okay.
So let's say this one here, we can call it depends on X, and then we say like do first, and we say like let's just like print line whatever is in X files. Yeah, I think we can just join to string and then do something like this. There's just one file in there.
I think I finally get it. Basically,
yeah.
So
now
X
you get
just collects all the files, right? X collects all the dependencies under that configuration, I would say. So that's why we have test and implementation. For the test, you have some additional classes which will not be available in production, right?
Yeah, exactly. And now here's like dependencies cannot be declared against the X configuration. I think you need to jump through more hoops to use the new APIs. Let's just use the old APIs. I'm pretty sure there are migration guides on Gradle, like how you would use the new API that is currently under incubating. So let's do compile. And could not resolve a dependency was declared on configuration default, which is not declared in the scripture of produce. And now you get into these problems where most of prior pay with Gradle comes from, which is like Gradle variant Davar resolution. It is exactly this question: how, either from a remote repository or from another project, how do I know from which configuration I get now things? Here's main elements. Here's utils elements. How do we select this? Like, how do we say that at some point we want to have like this X? Let's again call it main later on. How does this know what to do? What's the semantics? Like the semantics we can, and this is the confusing part, we can call it main here. We can call it main here. And it doesn't change a thing. It's just names of variables and how an entity has like, take it ID. It's not included. Nobody cares about what the name of this configuration actually is. But you see, there's semantics. Like we say main. We want the main part of this other project. Again, very similar to Kotlin, where you have like implementation, API, you have semantics to it, like meaning like this is just for the tests. This may be our test fixture, so I can request test fixtures. There's semantics, like I want this part from Kotlin. And if you think about it, Kotlin projects offer even more than just classes. They might offer you JVM classes. They might offer you Klibs for native. They might offer you even the sources for publication or JavaDoc if you want to request it. So how do you tell Gradle what you actually want? Now let's tell this. First, the producer needs to be kind of nice enough to also include the semantics. And here comes, Gradle has the concept of, and also let's just use regular create here. And let's do create and use the old APIs, which is in this case, is can be consumed is false, is can be resolved is true. This is exactly the thing that you need to do. And later APIs have other methods, but as you see, it's not even stable yet. So let's just use what's stable. Yeah, it can be consumed, true. It can be resolved, true. So here we tell just the configurations that yes, true, false. Yeah, we just tell Gradle this is outgoing, The other configuration is incoming. So they need somehow to match. And now what we need to do is like, we understand semantics of Gradle. And this comes with attributes. There are some really weird rules how Gradle does attributes, but the basics of it are simple. Let's use an attribute here. So we have, you see like attributes, we can have a block. And we can now say attributes, let's go and use a default attribute, like, let's create our own. Let's say use case or usage. No, usages case. No, I'm sorry, let's use the one of the default attributes. So attribute, you see like usage attribute, and now we need to specify usage attribute. We can create one by objects named usage, and we can specify basically whatever we like, main. Too many attribute, yeah. And now we say this one here is to be used as utils. Now we have specified a way how we can differentiate these two things. Like one says like, I'm used as main, I'm used as utils. This usage has like some really like a different meaning. In the end, we can look into it. It has something like Java API, it's native, it's a Swift API. You can see that usage differentiates, okay, this is a Java thing, this is something you can natively link against. We basically abuse it a little bit by just calling it main, which is like, okay, it's like, that's not what we actually want, but I just reused the attribute because it sounds what we want, like usage. We want to use this as main, we want to use this as utils. So let's also say this main here, when we request this, I want to also specify an attribute, like again, do the usage attribute, objects named, and then I think we can just go with this. Okay, let's ask Gradle if it actually can now find me the files. Again, oh, it now gives me producer build main jar. Let's ask in this configuration where we define main dependencies. Now let's ask and say like, hey, no, we want the utils. We want the utils instead. Let's compile again. Figured out that it matches when it now wants this project here, this producer project as a dependency. Yeah, it was now told in this dependency container that we called main. It was now able to figure out, hey, no, look for something that matches the attribute. There's a match like configuration that is defined as. Let's close other tabs and let's go producer, open it side by side. It now is able to detect like, okay, I requested the project producer in a way or a configuration that says attribute usage utils. So it looks for, okay, are there some configurations that are defined as consumable? Yeah, there are. Main elements is can be consumed true. Utils elements can be consumed true. Okay, we have two candidates. Now, how do we select from those two candidates? Let's look into usage attribute as we have defined it here. Yeah, there is usage attributes defined on both of those elements. Fair enough. Yep, there's one that matches exactly. So let's select main elements. Okay, how if I call this files? Where do we get the files from? Okay, we now look into this main elements. We match that. That's Gradle variant aware resolution. We match these elements. Very nice. Now we look into the artifacts. Okay, we defined an artifact. It's the main jar task. Oh, very well. Main jar task has these outputs again because we defined it here. Yes, I can find you the file. And here it is. And the interesting part, because we said that we depend on this as inputs, if I do dry run, you will see that it also has to produce the utils jar. And the cool thing is, it knows that it doesn't have to compile me or like build me this main jar because nobody cares, right? If I call this main, and if I want to compile here again, to the dry run, yep, it knows automatically, yes, in order to fulfill this request for you compiling, it has to do the main char compilation. Okay, with that knowledge, let's try to ask Gradle to resolve us Kotlin X coroutines from a Maven repository without the Kotlin plugin. Let's try to do this, and let's see how far we can get. Okay. So main,
Okay.
let's not.
Yeah, can I ask one question before we continue?
Yeah, sure.
So this means that whenever we have a sub project or sub module, for example, we have producer B. If you want to use it in the same way with the main configuration, that producer B should also have its own implementation of this configuration, right? For main, that it specifies usage attributes for main and utils,
Yeah.
right?
Yeah, and that's why it's so handy to have default Gradle attributes. Most of the time, you get completely, like, you can completely use this. So if you want to, for example, provide me class files, then I would just use the usage of here, for example, we would do something like usage.java API. And then you could do something like category. You can say like category from Gradle, category attribute, and you see like category, let's not use this. You can look at it and see like, okay, this is a library. It's not what it, like, you can say documentation, verification, platform and cross-platform library. And with this, you see like most of the things you actually would like to use, you can define as like, hey, I can give you this thing, and it's not me that says says what the attributes mean. I can just use default attributes from Gradle that will allow me to specify, okay, this is what the semantics of this artifact is. It can be used to compile Java with. It should be used in the API mode, not the runtime. You can also see that there should be something like Java runtime. Interesting. You can say like, this is from my library, this is the things you have to compile with, and these are the things you run with, meaning that some of the, you see like implementation dependencies, they should not be offered to the next one as a compile dependency. They should be treated as internals. So you can say like, hey, you know what? Or let's go with the example of, think of what happens if we are Kotlin Gradle plugin. Yes, of course, we have elements, and you will see that we have main elements, and we have main API elements, and we have main runtime elements. And this is exactly this. The main elements will offer you the transitive dependencies for things you can compile, and the main runtime elements will only contain the things that you have to run time with it. And so if Gradle wants to know, hey, give me all the files from the dependency that I need to compile, it will use the output from those files. If you say like, hey, now I want to do a run task, I want to execute the code, now it matches against the runtime elements, and it gives you more files most of the time. Okay, let's use Kotlin X coroutines and see like, let's call this task here debug. We run against main, and now we don't use the other project. We really want to use org JetBrains Kotlin X coroutines core, and then we say like 181 or so. I think 180 is definitely there. JetBrains Kotlin X. Okay. What happens if I now do debug? Oh yeah, no repositories defined. Makes sense. Repositories, Maven Central. Fair enough. Let's see debug. Okay, now here it is, the Gradle variant of a resolution error that nobody can read. And you can see now here the interesting things. All the variants, like what is here called a variant, is basically somebody declaring such a configuration. Okay, and what does it say? And now here's the, if you're able to solve such issues, you're already Gradle wizard. So it says, could not resolve all files for configuration main. Okay. Could not resolve Kotlin X coroutines 180. Okay. Required by project consumer, no matching variant found. The consumer was configured to find attribute usage with value main, but, and now here it lists all the variants that were published. You see like Android native, iOS simulator, JS runtime, a lot of attributes. And they're all marked as red with like, is incompatible because it says the usage is Kotlin API. Kotlin API. It says like something from like, it all says like it's incompatible with main. Okay, let's fix it. Let's say we want to use Kotlin API. Okay, now a lot of things should get compatible. So let's rerun. Okay, what does it do? Now it says something different. Could not resolve. The consumer was configured to find usage with value Kotlin API. However, we cannot choose between the following variants. Okay, now we see like there are a lot of things that would now be compatible because all of them have the Kotlin API. So they do not differentiate enough that we can pick one. And now we say unmatched attributes. We didn't say anything about artifact type. We didn't say anything about library, release status. We didn't say anything about the platform type. So, okay, let's ask for a specific platform type. Let's say we want to use macOS. So now, usually what comes here from usage attribute, if I would have the Kotlin Gradle plugin, I would get this attributes here for free. Now we need to create it. It's just strings, like nothing to be scared of. So what we can do is something like attribute of name. Let's do this, and it is string. Let's see, attribute of, what does it want? Of name is this, and then we have to provide just string. Okay. Platform type. So it's like, let's do platform type attribute. I just like, again, this will be offered by the Kotlin or any Gradle plugin that offers custom attributes. You see that such a Kotlin platform type is not relevant for Gradle because it's Kotlin specific, so it's not baked into Gradle. Now let's do attribute, platform attribute type. Now we specify, what did it say? It says something about native. Okay, let's go and say native. Let's see what Gradle does. Let's again, it's debug. Okay, we got further. Cannot choose between blah, blah, blah. And now we have all the native variants. So it says now we don't request category library. We don't request the release status and the artifact type. But we also say like there's a native target we can request, but the consumer didn't ask for it. Okay, let's try to differentiate by asking for a specific native target. So native target attribute. And it did it actually autocomplete. Okay, really cool. So what we do now, let's also specify that we care about macOS. So native target attribute, now I think it is iOS, like how does it say Linux, macOS ARM64, it's like this. Again, in Kotlin Gradle plugin, all of those strings would be typed and you can access them nicely. Let's see how far we can get with this. Oh, okay. You see what? We downloaded successfully Kotlin coroutines core, Caleb, and all of the transitive dependencies that are required to compile against, which is atomic foo, Caleb, and atomic foo, C and top. So we successfully downloaded from our Maven repository Kotlin X coroutines, the macOS ARM64 version, by specifying 3 attributes. First, the usage. We want to use it as a Kotlin API, so we can compile against. We said we want to have the native part of it. And to be precise, we said we want the macOS ARM64 native platform. And that was enough for us to resolve a dependency entirely without Kotlin Gradle plugin in the picture. So we were just able to download this dependency. So as a bonus, I think it might make sense. It might be nice if you can do something interesting. Come on, I consent. So coroutines for. We can look into how this was specified and how Gradle was doing this. So if you look into, let's use the same version here. We look into the files. The interesting part here, and I already downloaded it once for whatever reason, is this here. This is the interesting, pretty print. Oh, okay. Thank you. Thank you, checkbox. Interesting part here is this is how Gradle was able to serve us exactly the files. You see there's variants, and it is just a JSON file that encodes the attribute scheme and where to find the files. And you can see here, if you look for macOS 64 API elements published, you can see here, here's the attributes we requested: macOS ARM64, we requested native, we requested Kotlin API, and you can see here it says available at where to download this module. Now this module, again, module file contains the available at and knows where to download the actual libraries. But this is how Gradle did the magic. This is how we were able to now download this. So to reiterate, configurations are the powerful concept where you can declare what you want to share from like a producer perspective. Here we declared what we want to share and what is the semantics, the attributes, what this actually is, what we want to share. And then if you want to connect to projects and relying on each other, you use the Gradle's dependencies mechanism, and you say like, oh, I depend on this project, and let Gradle figure out, hey, in order to build these artifacts, I need to invoke those tasks, and they need those artifacts. So it builds up this tree of tasks, and it will be able to give you this up-to-dateness, and it will give you all of this, like doing things in parallel. So yeah, that's the crash course. I think we tackled the tasks, up-to-date checks, and configurations, and how Gradle actually downloads dependencies and how two projects communicate with each other. I think that's completely on point now. We have exactly about a minute finished.
This is amazing talk.
Yeah, really cool. Especially on the last part, I just it looked terribly confusing, but it's actually really simple.
Yeah. So, I mean, these configuration parts, I didn't see them. I think I never seen them in Android projects I worked for. So on basically we all used the pre-built implementation, test implementation, and other stuff. And this is like crazy. Now, when you explain it, so it's basically glorified file collector. You just specify rules by which you collect all the dependency files, right?
Yes. You know what? What is really nice is if you look into this main, you will be like you call it file collector, and I think you have a pretty good intuition. There's a type called file collection, and main is one of them. So yeah, your intuition was almost by every letter correct on what this is. It's a file collection.
Wow.
Yeah, and I think regarding configurations, damn, I think it's like somebody should be fired from Gradle, like or using configurations name, like I don't know, CEO or somebody who should be.
I will stop recording now if you're happy with this. So let's stop recording.